I'm Julie, from IXL with Julie, and in this video, I'd like to cover the topic of the least common multiple, the LCM, and the greatest common factor, the GCF. In this video, we will cover what they are, why we use them, 4 questions on the board, 2 questions in IXL, and then we're going to come back here for a recap of today's lesson. Now, let's go to the board. Now we're on the board, and I'd like to do some examples. But first, what is the greatest common factor? The greatest common factor, as the name suggests, is just a way to find the greatest common factor of 2 numbers. So now, let's get into the first example. But first, why do we use the greatest common factor, also known as the GCF? Well, we use the GCF for reducing our fractions. So, now let's get into the example. So, the first question we have is find the GCF of 18 and 36. So, what we're going to need to do is prime factor. Now, I did cover this in another video, which I will put at the end of this video, but I will do a review right now. So, 18. How do we prime factor this? Well, to factor this, what we have to do is we have to use our prime numbers to factor. So, first, we're going to try 2. And we're going to do this in order, so 2, 3, 5, 7. It is important to note that primes are important, and I also have another video on primes that I will also link at the end of this video. So, our first prime is 2. So we're going to try 2. So 18 divided by 2 gives us 9. So we do this, and then we put the answer right here. Now we know that 9 doesn't divide by 2. So we're going to move on to 3. So does 3 work? We know that it does because the divisibility rule of 3 tells us that if the digits added together gives us a number that's divisible by 3, we know that the number is divisible by 3. But since there are not multiple digits, we know that we can just try 9 divided by 3 mentally, and we know that 9 divided by 3 is 3. So we're going to put 3 here. And we know that 3 is divisible by 3, so we put the 3 here, and we put the 1 there. So this is written as 2 times 3 squared. Now we're going to run through 36. So for 36, what we're going to do is again start with 2. So 2 goes into 36 how many times? Well, it goes into 36 18 times. Then all we have to do is notice that 18 is the same here, so we just copy this. So 2, 9, 3, 3, 3, 1. There. Now, all we have to do is write it down here. So 2 squared times 3 squared. Okay? Now, we're going to write the GCF right here. So GCF equals. Then, we're going to bring down the smallest number, which actually contradicts its title. So, the smallest number between 2 and 2 squared is 2. So we're going to bring down the 2. Multiply that by 3 squared compared to 3 squared, which we know is the same. So we just bring down the 3 squared. Then we have 2 times 3 squared, and we know that 3 squared is 9. So 2 times 9 is 18. So our GCF is 18. Now let's go to the next example. Alright, now for the next example. We need to find the GCF of 9 and 49. Now, this is a more difficult example, but I'd like to run through it with you to show that the GCF can work for everything. So, we're going to find the prime factorization of 9 first. So, for 9, we know it's just 3 squared, because we did do this in our previous prime factorization, but you can also see it right here. Now let's do 49. And using our perfect squares, we know that 49 is 7 squared. So we're going to do 7 here. We're going to put 7 here, 7 here, and there. So we know that's 3 squared and 7 squared. Now the 7 should go past the 3 because it is larger. Doesn't matter which format you put it in, but I like putting it in order. So we have 3 squared, 7 squared. Now for both of these, they do not have a smaller, so the GCF is 1. Moving on to the LCM. But before we start the examples for the LCM, what is the LCM and why do we use it? Well, the LCM is known as the lowest common multiple. And as the name suggests, it helps you find the least common multiple of 2 or more numbers that are given. Alright, so now let's do the least common multiple, also known as the LCM problems. But first, I want you to know why we use it. And why we use it is quite simple. We just use it in math problems. Now, let's do the examples on the board for the LCM. So, the first question is find the LCM of 9 and 36. So, what we're going to do is again find the prime factorization of 9 and 36. So, find the prime factorization of 9. Again, we did this previously, so it's just 3 squared. I'm still going to write it out. I'm going to actually write 9 equals. And now we're going to do 36. So 36. Let's find the prime factorization. So 36 divided by 2 gives us 18. And again, we go using the same prime factorization for 18 as we used previously. So 2, 9, 3, 3, 1. So it's 2 squared times 3 squared. So I'm going to write 36 is equal to 2 squared times 3 squared. Now, I note that is not in line. You can put that way if you want, but for this, I put them out of order. Okay, so like GCF, we're going to write LCM here. We're going to write equals. But, again, it contradicts the title. So we're going to bring down the largest. So, what's the largest between 3 squared and 3 squared? 3 squared. What's the largest between 2 squared and nothing? 2 squared. So it's 3 squared times 2 squared. You get 9 times 4, which gets you 36. Now, let's do our last example on the board, and then we'll go into IXL. Okay, so let's find the LCM of 4 and 49. So, let's prime factor 4. 4, when we prime factor, we know is just 2 squared. So, we're just going to write 2 squared right here. Now, 49. We did use this in a previous example, so we do know that 49 is 7 squared, but we still want to show our work. So 49, we're going to do the prime factorization, and you get 49 equals 7 squared. Okay, now let's bring down the largest between the two comparisons. So, again, these are out of order, so these are in line, but we're not comparing the two, we're comparing the 2 with the blank spot and 7 squared with the blank spot. So, what we're going to do is, again, write the LCM equals. So, 2 squared and 7 squared, and again, this 2 squared is going with the blank spot, and this 7 squared is going with the blank spot. And then all you have to do is find the answer. So 4 times 49 gets you, let's do some quick math. So 49 times 4. 4 times 9 gives you 36. 4 times 4 gives you 16. Carry the 3, 196 is your final answer for the LCM. Now, let's go to IXL for some more examples. Before we get into IXL, I'd just like to show you how to use prime factorization on 49, as I realized that I sent some mixed messages. During the video, I told you that 49 was 7 squared, when previously I've told you to go 2, 3, 5, 7, and try each until you get to the number that works. So I'm just going to show you how to prime factor 49. Using divisibility rules, we know that 2 does not go into 49 because the divisibility rule of 2 tells us that if a number is even, we know it's divisible by 2, and 49, we know it's not even. So 2. Then what we're going to do is we're going to try 3. And we know that 3 doesn't work because 49 divided by 3 doesn't work, but also the divisibility rule of 3 tells us that if the sum of the digits is equal to a number that's divisible by 3, we know that the number is divisible by 3, but we know that 13 is not divisible by 3. Okay, now let's try 4. Now, the divisibility rule of 4 tells us that if the last 2 digits of a number are divisible by 4, we know that the number is divisible by 4. But 49 doesn't have the last 2 digits. 49 is the last 2 digits. So if you work it out, you get 49 divided by 4, and you get 12 and a decimal and or a remainder. So now let's try 5. Now we know that 5 doesn't work because we know that to work it has to end in a 5 or 0. Now let's try 6. Now I actually did get a comment on one of my YouTube shorts which gave an alternate way than I mentioned in the video, and it says that, in other words, if it's even number and its digits add to a number that's divisible by 3, it's divisible by 6. So shout out to that guy. So we know that this number isn't even, so immediately we know that doesn't work. Now let's try 7. Now we know that 7 works because if you just divide it out, because it is easier than just doing the divisibility rule of 7, because the divisibility rule of 7 is a quite complicated matter. So 49 divided by 7, you work it out, you get 7. So 7, and then 7 is divisible by 7, so you get 7 squared. To IXL, and then back to here for a recap.
Alright, so now we're in Excel, and I just want to go through a couple of questions. I'm going to read the question, and then we're going to work it out. A club has 14 girls and 7 boys as members. The president wants to break the club into groups, with each group containing the same combination of girls and boys. The president also wants to make sure that no one is left out. What is the greatest number of groups the president can make? Immediately, with the keyword greatest, we know that we're looking for the greatest common factor, or the GCF. So, what we need to do is prime factor 14 and 7. 14, we first try 2, because 2 is the first prime number, and we know 14 is divisible by 2, because the number is even. Then we're going to put our answer here. Then we have 7, and we know that 7 is prime, so here it goes, and then 1 goes here. So we have 2 times 7, and we know that 7 is a prime number, so I'm going to line this up here. Alright, we're not going to bring down the 2, because for the GCF, what we're going to want to do is bring down the smallest, and 2 compared to nothing is nothing, so nothing here. 7 compared to 7 is 7, so the GCF is 7. There will be 7 groups. Alright, now let's try this question. At a family reunion, each of Brenna's aunts is getting photographed once. The aunts are taking pictures in groups of 10, and the uncles are taking pictures in groups of 7. If Brenna has the same total number of aunts and uncles, what is the minimum number of aunts that Brenna must have? Using the keyword minimum, we know we're looking for the LCM. What we need to do is prime factor 10 and 7. When we prime factor 10, we first try 2, since it is the first prime number. We know it works. Put the answer here. 5 is a prime number. We put 5 there, and we put 1 here. 2 times 5, and we also have 7. I'm going to put a little space here, so they're kind of in order. Now, since we're using the LCM, we want to use the largest of each. 2 compared to nothing, we want 2, because that's the largest. 5 compared to nothing, 5. 7 compared to nothing, 7. Our final answer for the LCM is 70. Now back to the video.
Hi, welcome back. In this video, we covered the greatest common factor, that all it is a way to find the largest factor that goes into 2 or more numbers. We also learned the least common multiple, and that all it is a way to find the positive multiple that evenly is divisible by 2 or more numbers. We did 4 examples on the board, 2 examples in IXL. We did a review of topics that we've covered in these videos. We did a review of prime factoring, divisibility rules, and all these things build on each other. If you did happen to enjoy this video, please consider subscribing, as it helps out a ton and pushes these educational kinds of videos out to a larger audience. Thanks, bye!